So if there is selection, that will be combination, and if there is arrangement, that will be permutation. Okay, clear? This should be remembered. Okay, learn NPR equal to n factorial divided by n minus r factorial for the values of 0 lesser equal to r lesser equal to n. Okay, similarly, the formula of NCR equal to n factorial divided by r factorial into n minus r factorial. Okay, this is similar type of this, but here 1 by r factorial is extra. Okay, so this can be written as 1 by r factorial into NPR. Okay, so in short form this can be written as NPR equal to r factorial into NCR. Okay, this is the shortest form, and this is also the relation between permutation and combination. Okay, clear? Welcome back to our channel AnganaStudyCenter. Today we will learn about the combination, and then we will do some problem related to combination. Okay, and then we will solve the NCERT text exercise 6.4. Okay, so let's start our class. At first we will learn about combination. What is combination? Till now we have learned the permutation in different object taken are at a time. Okay, then the permutation means number of arrangement. Okay, permutation means number of arrangement, so the permutation is NPR. Okay, now the concept combination has been arrived. What is combination? Here in permutation we have learned the arrangement, and here in combination we have learned the selection. So if there is selection, then we have to do the combination, and if there is arrangement, so that was permutation. Okay, clear? In different objects taken are at a time. Okay, then the combination is are NCR. Okay, so for combination we use NCR, but we have learned in permutation we see NPR. That means this is the arrangement of n objects. Okay, taken are at a time. Okay, so this is arrangement, and this is the selection of n objects taken are at a time. So if there is selection, that will be combination, and if there is arrangement, that will be permutation. Okay, clear? This should be remembered. Okay, now we have learned NPR equal to n factorial divided by n minus r factorial for the values of 0 lesser equal to r lesser equal to n. Okay, similarly, the formula of NCR equal to n factorial divided by r factorial into n minus r factorial. Okay, this is similar type of this, but here 1 by r factorial is extra. Okay, so this can be written as 1 by r factorial into NPR. Okay, so in short form this can be written as NPR equal to r factorial into NCR. Okay, this is the shortest form, and this is also the relation between permutation and combination. Okay, clear? We have seen that NCR equal to n factorial divided by r factorial n minus r factorial. Okay, so here just see, if r equal to n, then what will be the value of NCR? Then NC, here r equal to n, so just putting this n we get. Here also n factorial divided by, here in r factorial, in the place of r factorial we put n factorial divided by into n minus r, that means n minus n factorial. So we have n factorial divided by n factorial into 0 factorial. Okay, so 0 factorial equal to 1, we have known from the previous class, and here n factorial will be cancelled out, so there will be 1. Okay, so the value of LCM equal to 1. Clear? This should be remembered. Okay, obviously this always follows this 0 lesser equal to r lesser equal to n. Okay, we have learned when r equal to n, so nc r equal to nc n equal to 1. Okay, and when r equal to 0, the value of this will be nc 0, that means just putting the value here, n factorial divided by 0 factorial into n minus 0 factorial. Okay, this will be n factorial divided by 0 factorial equal to 1 and n minus 0 equal to n factorial. So n factorial will be cancelled out. This will be 1. Okay, so we can write ncn equal to nc0. Okay, this is also important. Okay, if nc n minus r, there is nc n minus r, what will be the value of this? Just see here, just putting this formula, n factorial divided by n minus r factorial into n minus r, this is within second bracket factorial. Okay, so this can be written as n factorial divided by n minus r factorial, here n minus n plus r factorial. So n factorial divided by n minus r factorial into r factorial. This will be same as this, so this can be written as nc r. Okay, so we get nc n minus r equal to nc r. Okay, this should be remembered. Okay, nca equal to ncb. This implies that a equal to b. Okay, and implies that n equal to a plus b. Okay, if there is this type of problem, then obviously n equal to a plus b. Okay, this should be remembered. This is a theorem, ncr plus nc r minus 1 equal to n plus 1c r. Okay, just solve this. Apply the formula n factorial divided by n minus r factorial into r factorial plus n factorial divided by r minus 1 factorial into n minus r plus 1 factorial. Okay, equal, here this can be written as r factorial n minus r factorial, and this can be written as n factorial divided by r minus 1 equal to r minus 1 factorial, and here this can be written as n minus r plus 1 into n minus r plus 1 minus 1, that means n minus r factorial. Okay, so and here this can be written as n factorial divided by r into r minus 1 factorial into n minus r factorial plus n factorial divided by r minus 1 factorial into n minus r factorial into n minus r plus 1. Okay, so I am moving here, just look, just here this is common and this is also common. So if we common n factorial divided by n minus r factorial into r minus 1 factorial, so there will be 1 by r plus 1 by n minus r plus 1. So just solving this, n factorial divided by n minus r factorial r minus 1 factorial in, just LCM this, n minus r plus 1, here n minus r plus 1 plus r. So plus r minus r will be cancelled out. Okay, so here just look, n factorial into n plus 1. Okay, and here r into n minus r plus 1. Okay, into n minus r factorial into r minus 1 factorial. Okay, so if we taking these two, we get n factorial n plus 1 factorial, and here this will be r factorial, r into r minus 1 factorial equal to, and this is the n minus r plus 1 factorial. Okay, this will be n plus 1 factorial divided by r factorial into n plus 1 minus r factorial. Okay, this will be the value of n plus 1 c r. So we get this. Okay, just look at this. Here, if nc9 equal to nc8, find nc17. Okay, so we first apply the formula. Okay, nc9 equal to n factorial divided by 9 factorial into n minus 9 factorial. Okay, and this also n factorial divided by 8 factorial n minus 8 factorial. Okay, or here n factorial will be cancelled out. Okay, and there will be 1 by 9 into 8 factorial, and here n minus 9 factorial. Okay, and here 1 divided by 8 factorial into n minus 8 into n minus 9 factorial. Then n minus 9 factorial, n minus 9 factorial, 8 factorial will be cancelled out. So there will be n minus 8 equal to 9, or n equal to 9 plus 8 equal to 17. So here nc17 equal to, just putting the value of n, we get 17c17. So equal to 1. Okay, by the formula ncn equal to 1. ncn equal to 1. Okay, then another method. Here, then look, nc9 equal to nc8. So by the property of combination, we have 8 plus 9 equal to n equal to 8 plus 9. Okay, therefore n equal to 17. Just putting this value here, we get 1. Okay, now look at this question. A committee of 3 persons is to be constituted. I say in combination there is selection. Here, constituted from the group of 2 men and 3 women. Okay, in how many ways can this be done? Okay, and there is also another question: how many ways this committee would be consist of 1 man and 2 women? There is particular says that there should be 1 man and 2 women in 3-person committee. Okay, so for this first, the required ways are what? Here, total number of men and women equal to 2 plus 3 equal to 5, and from 5, 3-person should be selected. How many ways? So just here 5 see 3 ways. Okay, 3-person have been selected from 5. So this value will be, just putting the formula 5 factorial divided by 3 factorial into 5 minus 3 factorial. So this will be 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial equal to 2 into 1. Just 3 factorial cancel out, 2. That means 10 ways. Okay, and for the second, here just see, here we have 2 men among 5. Okay, among 2 men, 1 man can be selected. Okay, 1 man should be selected. So therefore the required ways are, when 1 man is selected from these 2 men, we get from 2C 1. Okay, and here also from 3 men, 3 women, 2 women can be selected. So this can be selected in 3C 2 ways. Okay, so just multiplying these to solve this. 2 factorial divided by 1 factorial, 2 minus 1 factorial, that means 1 factorial. Okay, into 3 factorial divided by 2 factorial, so 3 minus 2 factorial. So we have 2 factorial equal to 2 into 3 factorial equal to 3 into 2 factorial divided by 2 factorial. Just cancel out these 2. We have 6. Okay, 6 will be the answer. Then look at this question. What is the number of ways of choosing 4 cards from a pack of 52 playing cards? Okay, in how many of these? 1, 4 cards are of same suite. 4 cards belong to 4 different suite. 4 cards are face card, and 2 cards are red cards, 2 cards are black card. Cards are same color. Okay, so first we know that in 52 playing cards there are diamond, heart club. Okay. This diamond are of red color, heart will be red color, and spread black color, and this will be black color. Okay. And we also know that in diamond there are 13 cards, heart there are 13 cards, here there are 13 cards, and here there are 13 cards. So this is a suite, this is also a suite, this is also a suite, this is also a suite. Okay. Here total number of cards equal to 52. Okay. For the first question, we have 4 cards are of same suite. Okay. So if 4 cards are chosen from here, then the required ways are just 13C4. Okay. If 4 cards are chosen from here, so here also 13C4 ways. Okay. And here also 13C4 ways, and here also 13C4 ways. Okay. Just summation this. Okay. We get 4 into 13C4. Okay. Just calculating this, 4 into 13 factorial divided by 4 factorial into 13 minus 4 factorial. Okay. Therefore, we have 4 into 13 factorial divided 13 factorial equal to 13 into 12 into 11 into 10 into 9 factorial divided by 4 into 3 into 2 into 9 factorial. Cancel out 9 factorial, and 4, 4, and here 3, here 4, and here 2. Okay. There will be 26 into 11 into 10. Okay. Therefore 2860. Okay. This will be 2860. Okay. Now for the second, there is 4 cards belong to 4 different suites. Okay. I have 4 cards. Just imagine. Then there is question that 4 cards of 4 different that 4 cards belong to 4 different suites. So every suite have 1 card. Okay. So here is 1 card, here is 1 card, here is 1 card, and here is 1 card. Okay. So the required wizard 13C1 into 13C1 into 13C1 into 13C1. Okay. Among 4 cards, every card are available in every suite. So we use the fundamental theorem of counting. Okay. Just apply this. We have 13 factorial 1 factorial into 12 factorial. Okay. And this will be the same. So this to the power 4. Okay. Therefore 13 into 12 factorial divided by 1 factorial equal to 1 and 12 factorial. And this will be cancelled out to the power 4. That means 13 to the power 4 equal to 169 into 169. Okay. Let's multiply this, and this is your homework. Just do at home. Okay. For the question number 3, 1 are the face cards. Okay. We know among these 52 cards, there are only 12 face cards. So there are 12 face cards. Okay. So if we choose 4 cards from these 12 face cards, then the combination will be, so therefore the required ways are 12C4. Okay. Just solving this, 12 factorial divided by 4 factorial into 8 factorial. So this will be 12 into 11 into 10 into 9 into 8 factorial divided by 4 into 3 into 2 into 8 factorial. Just cancel out this 2, we get 3 will be cancelled out, and this will be 5. Therefore 45 into 11. So 495 ways. Okay. Now for the fourth, 2 are red cards and 2 are black cards. Okay. So here we have seen that here total red cards are 26, and there are also 26 black cards. Okay. So here 2 cards can be chosen from here and 2 cards can be chosen from here. Okay. So the required ways are just 26C 2 into 26 C2. Okay, just solve this. 26 factorial divided by 2 factorial into 24 factorial into 26 factorial divided by 2 factorial into 24 factorial. Okay, so we have 26 into 25 into 24 factorial divided by 2 into 24 factorial into, similarly this will be same, 26 into 25 into 24 factorial divided by 2 into 24 factorial. Just cancel out these two, and here 13, here also 13. 105625. Okay, for this 5, here cards are same color. So we have seen there are 26 red cards and 26 black cards. Okay, so if 4 cards are chosen from here and this 4 card can be chosen from here also. Okay, so the required weights are 26 C4 plus 26 C4. Okay, so just calculating this, 2 into 26 C4, just applying this formula, 26 divided by 4 factorial by 22 factorial. Just solve this, 2 into 26 into 25 into 24 into 23 into 22 factorial divided by 4 into 3 into 2 into 22 factorial. Just cancel out these 2. We have 2, 2, 4, and here 2, 12, here 2, 6, here 3, 2. So this will be 29900. Okay. Now we will do the exercise number 6.4 of your NCERT textbook. Okay, get this question. If NC8 equal to NC2, find NC2. We know, just comparing this, we get n equal to 8 plus 2, that means 10. Now putting the value of n, we get NC2 equal to 10C2. Just applying this formula, we get 10 factorial divided by 2 factorial, 10 minus 2 factorial. Therefore, this will be 10 into 9 into 8 factorial divided by 2 into 8 factorial. 8 factorial, 8 factorial will be cancelled out. Therefore, 5, so 45 will be the answer. Okay. Now for these two, we have, this can be written as by NC3 equal to 12 by 1. Okay. Just applying the formula, we have 2n factorial divided by 3 factorial into 2n minus 3 factorial. Okay, and this will be written as n factorial divided by 3 factorial n minus 3 factorial. Okay, here will be 12. Okay, just simplify. I am moving here. 2n factorial sorry, 2n factorial, this can be written as 2n into 2n minus 1, 2n minus 2 into 2n minus 3 factorial divided by here 3 factorial into 2n minus 3 factorial. Okay, and this part will be, we can write as in the form of multiplication. So this will be 3 factorial and n minus 3 factorial divided by n factorial. N factorial can be written as n into n minus 1, n minus 2 into n minus 3 factorial. Okay, equal to 12. Okay, just cancel out these two. 3 factorial, here n minus 3 factorial, n minus 3 factorial will be cancelled out. Here 2n minus 3 factorial, 2n minus 3 factorial will be cancelled out. And here just look, if we common 2, there will be n minus 1, or 2n into 2, then 2n minus 1 into n minus 1 divided by 1 into here 1 by n into n minus 1 n minus 2 equal to 12. Just cancel out n minus 1 n minus 1. Okay, and here n also be cancelled out, and here just cancel out this 6, and here 2 will be 3. Okay, so there will be 2n minus 1 equal to 3n minus 6, or minus n equal to minus 5, or n equal to 5. Okay, this will be the answer, and this is your homework. Okay, this is similar type of this. So now look at this question. How many chords can be drawn to 21 points on a circle? We know this is a circle. Okay, a chord can be drawn through 2 points. Okay, here 21 points. Just look. Okay, so by 2 points we can draw a chord. So by these will be very big, and from these will be we can draw. Okay, so 2 chords. So 1 chord requires 2 points. Okay, and 2 points should be chosen from 21 points. So the required number of chords are here n equal to 21. That means n object C 2. Okay, that means by 2 points we can draw a chord. So 21 points taken 2 at a time. Okay, just simplify this. 21 factorial divided by 2 factorial minus into 21 minus 2 factorial. That means 21 into 20 into 19 factorial divided by 2 into 19 factorial. Just cancel out these two. We get 210 will be the answer. Okay. Then look at this. Here, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys, 4 girls? So we have 5 boys, okay, and 4 girls. Okay. From here, 3 boys should be chosen, and from 4, 3 girls should be chosen. So from here, 3 boys can be chosen, and from here, 3 girls should be chosen. Okay. So the required ways are, just multiply the combination 5C3, that means 3 boys chosen from 5, selected from 5, into 4C3, 3 girls selected from 4 girls. Okay, just solve this. 5 factorial divided by 3 factorial into 2 factorial into 4 factorial divided by 3 factorial into 1 factorial. Just solve this. 5 into 4 into 3 factorial divided by 3 factorial into 2 into 4 into 3 factorial divided by 3 factorial. Just cancel out this, and we have 2. That means 20 into 2. That means 40. Okay, 40 will be the answer. Just look at this question. Find the number of ways selecting 9 balls from 6 red ball, 5 white ball, and 5 blue ball if each selection consists of 3 balls from each. Okay, so we have 6 red ball. Okay, here 5 white ball and 5 blue ball. Okay, so from each of these, 3 should be selected. From here 3 should be selected, from here 3 should be selected, and from here 3 should be selected. Therefore total selection 3 plus 3 plus 3, that means 9 ball can be selected from this 3. Okay, so therefore the required number of ways of selection is just 6C3 into 5C3 into 5C3. Okay, just solving that, we get 6 factorial divided by 3 factorial into 3 factorial into 5 factorial divided by 3 factorial into 2 factorial into 5 factorial divided by 3 factorial into 2 factorial. Just simplify that, we get 6 into 5 into 4 divided by 3 factorial into 3 factorial. 3 factorial will be cancelled out, and therefore there will be only 3 factorial. Okay, and here also 5, 4, 3 will be cancelled, 3 factorial will be cancelled out divided by 2, and here also be the same value. Okay, so 3 to 6 will be cancelled out, 2 to 4 will be cancelled out, therefore into 5, that means 2000 will be the answer. Okay, now look at this question. Determine the number of 5 card combination out of a deck of 52 cards if there is exactly one ace in one combination. Okay, so there are 5 card combination. If there is one ace, that means remaining 4. Okay, so just look, among 52 cards there are 4 ace. Okay, 4 ace card. So if we take, just imagine, here the combination of 5 cards. Okay, and this is S card. Okay, so there is only 4 cards, and among 52 there are 4 S. So this S card can be chosen from 4, and rest 4 cards can be chosen from 50 minus 4, that means 48 cards. Okay, so the required number of 5 card combination is, here one S card can be chosen from 4, that means 4C 1 into, and the rest 4 card can be chosen from 48C 4 ways. Okay, just solve this. 4 factorial divided by 3 factorial into 48 factorial divided by 4 factorial into 44 factorial. So we have here just 4, and here 48 into 47 into 46 into 45 into 44 factorial divided by 4 into 3 into 2 into 44 factorial. Just cancel out these two, and we have and this will be 77, 83, 20. Okay. This question: in how many ways can one select a cricket team of 11 players from 17 players, in which only 5 players can bowl? Okay. So among 11 players, 5 players can be ball. Okay. If each cricket team of 11 must include exactly 4 bowlers. Okay. So among 17 players, there should be 5 players who can bowl. Okay. So just look, bowler and here batter. Okay. So here among 17, 5 are bowler and rest, that means 17 minus 5 equal to 12 are batter. Okay. Among these 5, 4 should be bowler. So 4 can be chosen, selected. 4 should be selected from these 5, and rest there are 11 minus 4, that means 7 should be selected from 12. Okay. So the required number of ways are 5C4 multiply 12C7. Okay. Just solve this. 5 factorial divided by 4 factorial into 1 factorial into 12 factorial divided by 7 factorial into 5 factorial. Just calculate this. 5 factorial, 4 factorial, that means 5, and here 12 into 11 into 10 into 9 into 8, and 7 factorial will be cancelled out, and here will be 5 into 4 into 3 into 2. So 5 will be cancelled out, and 4, 3, 12 will be cancelled out, and here 5 will be cancelled out. So 11 into 9, 45 into 11 into 8. Okay. So we have 3960 will be the answer. Okay. Now this is very easy. A bag contains 5 black ball and 6 red ball, and from which determine number of ways in which 2 black ball and 3 red ball can be selected. So 2 black ball can be selected from 5 black ball, and 3 red ball can be selected from 6 red ball. So the required number of ways are 5C2 into 6C3. Just calculating this, we get 5 factorial divided by 2 factorial into 3 factorial into 6 factorial divided by 3 factorial into 3 factorial. We have 5 factorial equal to 5, 4 into 3 factorial divided by 2 into 3 factorial. So cancel out, into 6 factorial equal to 6 into 5 into 4 into 3 factorial divided by 3 factorial equal to 3 into 2 into 3 factorial. 3 factorial will be cancelled out. 3 to 6 will be cancelled out. Therefore, here 2 will be cancelled out. Therefore, equal to 10 into 20. That means 200. Okay, 200 will be the answer. Look at this question. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Okay. So total course equal to 9. Okay. Among these 9 courses, 2 are compulsory. Okay, and remaining 9 minus 2, that means 7 can be chosen. Here total course he should take total 5 course. If 2 courses are compulsory, then there is 5 minus 2, that means 3 course. So among these 7 course, 5 minus 2 additional equal to 3 course can be chosen from the 7. So the required number of OS is just from these 2 he should select 2 compulsory. This is compulsory. So 2C 2 into here from 7 he select 3. So 7C 3. Okay. Just calculating this. This is 1 and this is 7 factorial divided by 3 factorial. So 7 minus 3 factorial. So this will be 7 into 6 into 5 into 4 factorial divided by 3 into 2 into 4 factorial. Just cancelling these 2, we get 3 2 equal to 6. 35 ways. Okay. This will be the answer. So that's all for today's class. We will learn in this class the combination, what is combination, various theorem of combination, and do some example and complete all the exercise 6.4. Just practice all the things we have covered in this video. Okay. If you like this video, please subscribe our channel and share with your friends. Thanks for watching our video.